Why is functional programming elegant for conditional logic? Imagine trying to solve a puzzle where each piece fits perfectly without forcing or twisting. That's what makes functional programming so appealing when handling conditional logic. It keeps your code clean, simple, and easy to follow. Instead of writing long chains of if-else statements that can get tangled, functional programming uses clear and predictable methods. In traditional programming, you might have nested if-else blocks that are hard to read and even harder to troubleshoot. These can cause logical errors if you forget to cover a case or accidentally write the wrong condition. Troubleshooting such bugs can feel like searching for a needle in a haystack. But with functional programming, the focus is on pure functions. These functions take inputs and give back outputs without changing anything outside. That means their behavior is always the same for the same inputs, making bugs easier to spot. Another big advantage is avoiding mutable state. When you change variables or data inside your code, it can lead to unexpected bugs. Functional programming keeps data immutable, so you don't have to worry about side effects messing up your conditional logic. Instead of relying on complex if-else chains, it often uses data types like enums or algebraic data types. These types explicitly list all possible cases, and pattern matching handles each one. This way, you know all conditions are covered, and missing a case becomes much less likely. Higher order functions and lambdas are also part of the picture. They let you pass functions as arguments, which can replace many conditional statements. This makes your code more flexible and easier to understand. Instead of writing a bunch of nested conditions, you can compose functions that handle different scenarios. The overall benefit is that code becomes more transparent. Clear function names and straightforward data transformations make it easier to see what your program does. When bugs happen, you can isolate them quickly because each function is self-contained and predictable. Testing becomes simpler too, since you can test functions independently with known inputs and outputs. In the end, adopting functional programming techniques for conditional logic reduces errors and makes fixing bugs faster. It prevents many common logical mistakes like missed conditions or incorrect branches. Replacing complex if-else chains with pattern matching or function composition keeps your code tidy and less prone to bugs. This approach makes your code not just easier to read but also more reliable, especially when troubleshooting errors related to incorrect conditional logic.